Hi everyone, welcome to part 2 of section 7.2. This time we're going to look at negative rational exponents. So we're going to build off of what you have already learned about negative exponents. So as a reminder, please remember that a negative exponent does not indicate that the expression itself is negative. So for example, say we look at something like 25 and we're going to raise it to the negative 1/2 power. This does not mean that our final answer will be negative, okay? So to be clear, we're still going to work with very similar rules that we had when we were working with just negative exponents, so before we were putting fractions in that position. So what I want to note here is that because of this negative, we can kind of say that 25 is unhappy. So if you want to start attaching emotions to your problems, if you aren't already doing that already. But what we want to note is the 25 is unhappy in the upstairs position. So I'm going to move it to the denominator. And by moving it, that makes the exponent positive. If we were to go ahead and go further, so to kind of investigate, what we can notice is I have a denominator of 2. So if I were to rewrite this from the exponential expression to a radical one, we could write this as 1 over the square root of 25. And hopefully what we remember is the square root of 25 is 5. Notice that the answer that we get is positive, so it has nothing to do with the sign of the exponent, okay? The sign of the exponent is really just kind of telling you about the position that you should be moving your expression into. So let's go ahead and do a little bit more of a complex example. We're going to work with 16 raised to the negative 1/2 times p raised to the 2/3 times w raised to the negative 3/5. And what I would say is take this piece by piece. And maybe what you might want to do is first begin to shuffle things so that you no longer have negatives in your exponents. So I might go ahead and start off by looking at 16 raised to the negative 1/2 and kind of know, it's not happy, so I'm going to move 16 below, and that exponent is now a positive 1/2. Continuing, if we take a look at p raised to the 2/3, p raised to the 2/3 is good. So it's happy where it's at, so I'm going to let it chill out where I found it. The next one, w, not the same story. W is cranky, so we're going to let w go downstairs as well. And from here, we can go ahead and we can see if we can actually simplify some things out. So I'm noticing really quickly, and I'll kind of demo this as an aside, so in other words, I'm just thinking on the side of my paper. Take a look at that 16 raised to the 1/2. Again, if I were to write this instead of an exponential into a radical, I can note that my denominator is a 2, so I have a square root of 16 raised to the 1st power, or in other words, just 16. Well, the square root of 16 is just 4. So I could rewrite this as p to the 2/3 all over 4 times w raised to the 3/5. Okay? So the other thing to note, so maybe some of you are kind of like wondering, well, what about the, say, p raised to the 2/3? What I want you to note here, and again, we'll kind of do another aside to demo it. Say you're working with p raised to the 2/3. Again, the denominator is 3, so that means I can write that so that it is a cubed root. And this is going to be p squared. So I only have 2 of that variable underneath a cube root. I don't have enough to move it out. So there's really no point in writing it this way. I can leave it as the 2/3. And the same argument can be made for w raised to the 3/5. Feel free to pause the video and give it a try. But what you're going to note is that you're going to have 3 w's underneath a 5th root. There's not enough of them to escape. So this is my final solution. So what I would encourage you to do next, before you proceed through the video, is try out the 4 practice problems. After you've done attempting them, whether you are successful through all of them or just a few, what I would encourage you to do is to pause the video, work on them, and then come back and go through the answers, making any corrections or adding any additional notes that you find might be helpful for when you go back to review your notes. All right, so I'm going to go ahead and move forward. So at this point, I would recommend pausing. So let's go ahead and take a look at 10,000. And we're raising that to the -1/4. So again, I'm noticing there is some unhappiness in my problem. So what I can go ahead and do is I'm going to move my 10,000 downstairs, which allows my exponent to now be written as a positive exponent. The next thing that I'm going to note is that I have a 4th root because there is a 4 in the denominator. So this means I now have 1 over the 4th root of 10,000. The reason why I'm looking at this is because I think that I might actually be able to evaluate this. So in other words, I'm going to get a nice integer value out. I'm not going to have any kind of nasty run-on decimal values. So if I do go ahead and play with this, what I want to note is 10,000, maybe start dividing by tens. So that would break down to 10 times 1,000. I can break my 10,000 down into 10 times 100, and I can break 100 down to 10 times 10. You technically could break these 10 downs further into 2s and 5s, and if you would like to, you should still end up coming up with the same solution. But what I'm noticing as I was going ahead and beginning to deconstruct this number, breaking it down into some factors, I have 1, 2, 3, 4 identical 10s. So that means I can rewrite this problem as 1 over 10. Again, because I have a group of 4 underneath a 4th root. Let's move to 1/8, and that is being raised to the -2/3. So what I want you to note for this problem, remember that you can rewrite this so that the exponent can go to the value in the numerator and to the value in the denominator. So we'll have 1 raised to the -2/3 all over an 8 raised to the -2/3. So emotions are still kind of running, well, negative. So we gotta shuffle some things around. So because 1 is unhappy upstairs, I'm going to move it downstairs. So we would have 1 over a positive 2/3 now. And because the 8 is unhappy downstairs, I'm going to move it upstairs. So I have 8 raised to the positive 2/3. So please note that with regards to the denominator, you have 1 raised to a 2/3. 1 raised to any exponent will always just be 1. So technically, what I have here is just 8 raised to the 2/3 divided by 1. Well, that's no different than just working with 8 raised to the 2/3. Let's see if we can clean this number up. Okay, so let's make sure that we can clear it all out. evaluate it completely so that we don't have anything left under the radical. So again, I'm noting that my denominator is 3. So this is going to give me a cubed root of 8 squared. We can play with this a little bit more. Okay, so underneath my cubed root, I can write that as 8 times 8. So I'm just expanding it out. And note that with an 8, I can break that into 4 and 2. And those 2's are primes. I can take my 4 and I can also break those into 2's, which are now prime numbers. I have a cube root, which means that I have to have 3 of the exact same number in order to break it out. So in this case, I can take out one group of 2 and then a second group of 2. This means that I'll have 2 times 2, which is equal to 4. So if we come back to this, 8 to the 2/3 is just 4 over 1, or my final answer is just 4. Let's make some room for the last 2. Okay. We'll take a look at 5 times x raised to the negative 2/3 times y raised to the positive 4/5 times z. So this is very similar to the first problem that I modeled with you. So we're just going to check through. So 5 seems happy. If I need to actually see the exponent, this 5 is being raised to a positive 1. So 5 is just going to stay where it's at. It's a different story for x. X is not happy. So I'm going to move x to the denominator position. Y is happy where it is at. And z seems pretty cool too. So z again would also be raised to a positive 1. So there's really not much else that I can do here. Okay, we're done. That's my solution. So the next one, scoot that out of the way. We're going to look at 7x all over 8 times y times z, and we're going to raise that to the negative 3/5. Okay. So again, we can kind of do something very similar like we did with the 1/8 raised to the negative 2/3. So I can give the negative 3/5 to the top product and to the bottom product. This is going to give me 7x, that whole thing raised to a negative 3/5. And then I can do 8yz, that whole thing raised to the negative 3/5. Okay, emotions are still running high. So the 7x is unhappy, the 8yz is unhappy. So we're going to move things around. 7x, you're moving downstairs. And then the 8yz, you're moving upstairs. And I need to make sure that I don't get sloppy. I still want those grouping symbols around there. So if anyone was asking themselves that question, I'm glad that you were checking into that. Looking at these, you can play around with them, and for the sake of the time of the video, I'm just going to kind of note that I really can't cleanly evaluate, say for example, like 8 raised to the 3/5 power. You would be able to pull some numbers out, but you would still have some underneath the root. So because of that, and like it's not necessarily wrong, but it just looks a little bit more complex, I'm going to leave everything as is. The only step that I would say is, again, note how the numerator is raised to the 3/5 and so is the denominator. So they're still being raised to the same exponent. We could write this in that shorthand again, so we could do 8yz on top and then 7x on the bottom and then just raise it to that 3/5. Okay, this is what your final answer can look like. I hope this video was helpful. If you have any other questions, please let me know.